So we're going to go to Tinkercad today. Now you're going to go to tinkercad.com, just like it says right here, tinkercad.com. There's a link in your assignment. But if you get lost, click these three colors. You should always see this 3 by 3 square. Click it. It.
You're not showing your screen.
Oh yeah, yeah. Thank you. Let me share my screen first. That's a good idea. All right. So if you ever get lost and you're on tinkercad.com, just click these 3 by 3 colored square in the top left corner. It'll send you back to this place. And you're going to click circuits. We're not going to do 3D design. We're going to click circuits. And we're going to click new. And once we do that, we're going to um, we're going to learn how to use a breadboard. Now, we use these in class in real life. We really do have one of these. Okay, so I just grabbed it over here. It says breadboard small. So we actually do have these in class. And we have different sizes. For freshmen, usually we use these small ones because we don't do much on them. In digital electronics class, we have really, really big ones. Um, and we have a bunch of loose parts like this in the class. I have pretty much everything you can find here in class. Um, but the cool thing is works exactly the same as real life. They did such a great job at doing this. Um, so if I click an LED, and I'll put off to the side here first and zoom into it. Here, actually, let me bring it here. Notice this bent side. That's going to be your positive. It's called an anode. And this shorter side, that's called a cathode, and that's your negative side. So let's just lay it in there. And the way a breadboard works is these power rails right here. You see when I hover over them, you see how they all turn green. If I plug anything in here, like doesn't matter here, here, here on the left, it electricity will travel all the way down this road. There's a bar of metal underneath. Same thing here. If I plug something here, like this little dot here, it will connect to anything all the way down, even all the way down to this other side. But these are not connected to each other. These connect this way. So if you look, this row is connected to this row. If I plug something here, it's connected to something I plug here, 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 or here. But they are not connected to this side. They are not connected to the one next to it, and they're not connected to the one next to it here. They're just only connected in that row. So when I do this, let's say I put the LED here. The cool thing is I can plug something in this row or this row, and it connects to this leg and this leg, because it's kind of hard to connect to it otherwise. So you just jab them in these holes, and then you can connect to them. So remember, this is the positive side, the one with the bent leg. We'll remember that for a minute. So let's grab a battery. And it's very common, this is negative. It's common to kind of put your power, let's say, you put them in the power rail. So I'm going to put negative up here, and then I'm going to put positive. If you want to see where I put it, I put the negative there. And this positive one, I'm going to connect it here. Okay. Now I've seen some teachers, they'll say, hey, yeah, just use them like that. That works, but in real life, I don't like to do that because if they're hanging out a little loose and they touch each other and they're really close by, they can short each other out and cause, burns and stuff like that. So I keep them far apart. Next, you're going to use a button. So today we're going to learn how to use this button, and the button we're going to put it not here. It's got to go right here separated. So the four legs, 1, 2, 3, 4, are not touching. If I put it here, let's say here, right here, this leg is connected to this leg automatically. This leg is connected to that leg because remember, this whole row connects to each other. See how they all connect, right? You see how these whole rows connect. So this leg is connected to that leg, and I don't want that. I want all four legs separated. So we'll just put it here. Okay. Now you could technically hook it up right now, but in real life, you would burn this LED out. You would destroy this LED if we hooked it directly right now. Let me show you what I mean. So this side's negative, right? So I'm going to connect this side to the negative, and the positive, I'm going to connect it from here to the switch. See, it connects here. And when I push the button, it comes out on the opposite side, by the way. So just know that. So when I push the button, electricity travels from here to here. Or from here to here. Doesn't matter which way you use, but they come out diagonal. Okay? Now, so that means I can take this and make it run right here. See? So electricity goes in here. So let's just follow the path. Positive goes here, comes up here, goes into this leg, push the button, it comes out this way, goes into this hole. There's nothing else here. Make sure that's the case, that there's nothing else here. Sometimes students will like, yeah, it's going to go in here, it's going to go in here, but they didn't notice there's a leg, something here. So it goes over here, and it connects into this row, which goes to the positive leg. Perfect. Now, if I push start simulation, and I push this button, electricity will flow, and it'll turn the light on, but it'll probably pop the light bulb, it'll destroy it. See that? Boom, and it's got an explosion. So that's not good. And the reason being is, I'm going to delete this, is when you send electricity to an LED, you should always slow it down with a resistor. LEDs don't use much power at all. So I got to rotate this thing around. How do I rotate this? Right here, I think. Let's click this. Nope. It's this one right here, this one. And you see, the resistor is connected here, and electricity is going to go here, go through the resistor and connect here, and it goes here. Oh man. Well, now it's not connected to this, so I'll just move that over, and I'll move that to there. There we go. So the negative side is always connected to the negative. And when I push this button, the positive will go through here, go in here, go through the resistor, and go here. And let's go ahead and click that resistor and change it to a good resistance. So make sure this is in regular ohms. In other words, it's not milliohms or kilo ohms, just regular ohms right here, the little horseshoe symbol. And about 330 is a good value for protecting a LED. In my electronics class, you can use 100, 200, 300, 400, 500, but 330 is a very common value. So let's push simulation, and let's push play. It works. Every time I click this button, it works. It turns the light on. It works just like it would in real life. And it doesn't matter how you do this. So if you were to do it on the other side, it's not like it only works in certain ways. So as long as it works, so you can connect it here. We can move this here. We can move this here. We can move this here. We can put the negative here, and we can delete this. And there we go. That should work as well. Let's follow. Positive. Remember, current travels from positive to negative. So positive, down to here, into this row, which goes into here. When I push the button, it comes out diagonal, goes here, goes into here, and goes to the positive side, which is good because this is the positive side, right? So it goes to the positive side. The negative side is always connected to the negative, which goes back to negative. Yep. So this should work. Let's try this out. Works fine. Okay. So if you build this, you're going to get an 8 out of 10. That's a B. If you play around with it long enough to make make 2 lights, try to figure out how to make 2 lights, I'll give you the full credit, 10 points. And that's it.